Addiction is defined as not having control over doing, taking, using something to the point where it could be harmful to you. Previous to understanding the science, it was thought that addiction resulted from a lack of willpower and was a moral failing. But we now know that addiction is a physiological disease. It changes the brain structure in ways that can alter the way it works and process information. To understand how that happens, we start by thinking about reward and the brain's natural reward system. The reward pathway's primary function is to reinforce sets of behaviors. Evolutionarily, it began as a way to indicate to us that actions that help us survive are good and we should keep doing them. This is mediated through a chemical called dopamine. Following an appropriate behavior, the reward pathway releases a small burst of dopamine. That burst of dopamine is a satisfying jolt, encouraging you to repeat the same action in the future. Dopamine will in turn also act on areas responsible for memory and movement, which helps us automatically build up memories for what is good for survival. The problem is that addictive substances hijack our natural reward system. Every substance has slightly different actions on the brain, but one thing all addictive drugs have in common is that they produce a pleasurable surge of dopamine. Addictive drugs all cause dopamine to flood the reward pathway 10 times higher than a natural reward would. Over chronic use, nothing else natural is quite as rewarding. In fact, as substance use increases, the circuits adapt and reduce their sensitivity to dopamine, a phenomenon known as tolerance. For example, let's say a person takes cocaine for the first time. The reward system receives a huge burst of dopamine. But as the person takes more frequently, cocaine will be overstimulating the brain with dopamine. This will cause the brain to adapt to these chronically high levels of dopamine. To compensate and adapt to this new normal, the brain reduces the number of dopamine receptors available in the reward system and releases less dopamine. As a result, that person will feel the need to increase the amount of drug they take so that they can reach the level of high that they're used to. But it's not just the reward system that's affected by this tolerance.
You okay?
Since dopamine is also involved in other brain mechanisms. Other brain regions involving decision-making, memory, and judgment also get physically disrupted as a result. The overall effect is to have drug-seeking behavior driven by habit rather than conscious thought, like a reflex instead of a choice. This biological basis helps to explain why addiction really is a brain disease, not a matter of willpower. The stigma that accompanies addiction only makes seeking treatment more difficult.